Okay, so to pick it up with the second video, I actually noticed that I think there's a mistake in this slide as I'm kind of looking at it while I'm talking. So it's just like class. In this case, the workers are 5 times more productive than the capital. Right, or it's 5 times more expensive, right? $10 versus $2, but they are equally productive. And then the question is, which input would the producer use more of? They should be using more capital, not labor. So I think what I meant to say is capital, because it is cheaper. And as they use more capital, then the MPK is falling. But then labor would be decreasing, which would raise the MPL. So I think you just need to you need to reverse all these. I'm not sure what, I may have just like changed these numbers in making the slides, but forgot to change the explanation. Again, looking at this, I think you need to switch the labor and capital references from the sub-bullet point down for it to make sense. Okay, so then when we put everything together here, then we see this cost curve, this cost thing should look, or cost schedule should look familiar to you. It indicates that the fixed costs are not changing, the variable costs are initially increasing at a decreasing rate, which you can see by the marginal cost getting smaller and smaller and smaller, and then increasing at an increasing rate, which you can see by the marginal costs getting larger and larger and larger. And then the averages sorted out on their own. These cost curves look exactly the same as you would expect. And again, then when we put this all together, we find our optimal point as L1, K1, the point of optimality, and in this case, deciding we want to produce Q1, but we want to do it at the minimal cost. So we're trying to find the lowest ISO cost just tangent to the isoquant. I'll repeat that again. We're looking for the lowest ISO cost, the lowest ISO cost curve just tangent to the isoquant. Okay. So when we're trying to cost minimize, again, we'll set the productivity per dollar spent for each input would be the same. And what we can do is we can combine all those points, create what's called an expansion path, which would combine all of the cost minimizing combinations of labor and capital for each unit of output. And you see that here. It basically, if you remember back from the earlier section, this would be the equivalent of the price consumption curve. Basically combining all of the lowest ISO costs for all of the different isoquants. And that expansion path basically has the exact same information as the long run total cost curve. That long run total cost curve starting at 0, because you could completely shut down, and then simply follows the exact same expansion path. Okay. In terms of the, what is it that differentiates a short run versus a long run? And that would be the fixed cost. In the long run, there would be no fixed cost because you can change everything. Now, that would mean then that there is a difference between a long run expansion path and a short run expansion path. In the short run expansion path, you'll note that the capital is fixed at K1. And you can see that in this description right here. But in the long run, we can change labor and capital. And so we can go, we can increase, and for the second point, we can increase our capital, move from L1 to L2, which is a much better way of producing Q2 than saying we have to stay at K1 and we have this whole bunch of labor to produce that amount. So you can see why short run production is so inflexible as well as inefficient. Okay, in terms of the tax treatment, let's just neglect this for right now. We're kind of running out of time even this semester. I don't think I impose any problems for you to do with regard to this, so let's just skip 107. Now, when we look at the long-run average cost curve, it's basically an envelope of all of the short-run average cost curves. And now, right, we're looking at how the returns to scale figure in and contribute to the average costs. Right, we know that the average cost curve is going to be U-shaped. It's going to be U-shaped due to the returns to scale. And what are we going to see here is that we're going to have a long-run average cost curve. We're also going to have a long-run marginal cost curve, where the long-run marginal cost curve intersects the minimum of the long-run average cost curve, as we would see right here. And why is it that when the firm is producing more, the average cost is likely to decline in the beginning? Because essentially the firm is getting better, finding a better way of organizing their activities. It's producing things in a more effective manner. The workers are becoming more specialized. And when we look at why then it starts to increase eventually, we can basically say the firm is basically too large, becomes inefficient, maybe too complex in what it's doing. And the consequence of that is that the expansion path no longer becomes a straight line, that the inputs required start to increase at an increasing rate, which then gives rise to something known as the economies of scale. And the economies of scale are describing the long-run average cost curve, where we have economies of scale in the beginning and then diseconomies of scale in the end. How do we measure these economies of scale? Well, it's actually a cost-output elasticity, where it's actually measuring percentage changes. The percentage change in the cost of production versus the percentage change in the increase in input. This is different than returns to scale. If you remember, returns to scale was number of inputs, number of outputs. Economies of scale is talking about cost of production and change in output. Because it's talking about cost of production, that's why we're talking about the average cost curve. Economies of scale are equal to 1, basically at the minimum of the long-run average cost curve. Economies of scale would be in the very beginning. And then diseconomies of scale would be when the marginal cost and the average cost are rising, which occurs in the right-hand side of the average cost curve. This would be, right, if we go back to here, what we see economies of scale, we see right here, in this first half. Economy of scale like equal to 1 right here, and then diseconomies of scale on this half right here. Okay, the cost curve itself then, when we look at how it's shaped, it's actually coming about from all the short-run curves. It's actually an envelope of that curve. You can actually see that in this slide here, right? All of the short-run curves are actually forming the shape. If I had drawn more short-run average cost curves, you could see actually even more precisely the long-run average cost curve. Now, if I remember correctly, if this is all learning by doing, yes, I'm not going to hold you responsible for the remainder of these slides. Learning by doing is something, while significant and important to some extent, we're just running out of time, and I've got more than enough questions that I want to ask you and focus on. This isn't on the problem set. It's not covered in most intermediate microeconomics courses, and I want to focus on your mastery of the core material rather than doing a whole bunch of extensions. Okay, so that ends the second video, and so I'm hoping that you're going to watch these then next week, and that then we're going to work on the problems upon my return. Okay, so start to work on the problem set, and then we'll talk about those on the 2nd of April.